Hi folks, Oak Barrett here. Two things I've been around the majority of my life are databases and baseball. The True Fall Classic begins this Friday as the New York Yankees and the Los Angeles Dodgers meet in the 120th Major League Baseball World Series. To commemorate this event, I wanted to play around with Snowflake and the Lahman Baseball Database. Recently, I completed Snowflake's 5 hands-on essentials courses, covering data warehousing, data apps, data lakes, and data engineering. In an effort not to waste any of my remaining Snowflake credits, I decided to port the Lahman database over to Snowflake. Most of you watching may already be aware of the Snowflake platform and its AI Data Cloud capabilities, but many of you may not know about the Lahman Baseball Database. Sean Lahman is an author, journalist, and member of SABR, the Society for American Baseball Research, the folks behind Sabermetrics. Sean has been keeping a database full of MLB stats since 1992 when he ported it from DBase. And in the fall of '96, he released his Microsoft Access and CSV files to the public. The 2023 MLB dataset was released earlier this year. This dataset's been the foundation for class assignments across many universities, including Cal Berkeley, University of Michigan, Baylor, Carnegie Mellon, and others. A couple of weeks ago, Sean donated the open source database to SABR. So let's get started. At a high level, I'm going to share some of my experiences with the data acquisition, modeling, staging, and loading and exploring of the data. Then on the querying side, explore Snowflake's Copilot's AI Generative SQL capabilities, as well as some handwritten SQL to see what types of insights we can come up with in this dataset. Sean licenses the database under the Creative Commons Attribution Sharealike 3.0 license, which I'll post below in the description of the video. In Sean's README, he lists the 27 CSV files that you'll find in the download. And he goes into detail of the topics of each table and the columns that are contained within each table. And although Sean provides versions for Microsoft Access and Microsoft SQL Server, the CSV files do not have a prepackaged DDL to create your database tables, so you're going to be on your own for that one. All right, so I downloaded the comma delimited files from Sean's website and unpacked them into a directory on my computer. Double checked that I had 27 CSV files. I like to use a terminal window and grab the header line of each file, and that way I could take a quick glimpse of the file structure if and when needed. As mentioned, you're going to need to create your own table DDL. You could look around and find partial ERD diagrams out there on the web to help you model the tables, or you could read the details of the README to pick out data types and whatnot, or you could search for a data model that's already been created. So I've used this model by Brent Nycombe in the past. I used it to load a Postgres-based Greenplum database. And it was a good starting point for me then. So I'm going to try it again now, knowing that I may have to make some tweaks either for Snowflake specific or just changes in the data model since this model's 6, 7, 8 years old. I will leave links to the repos used in the video description below. One thing that I appreciated that Brent did was that he prefixed any fields that began with a number, like 2B or 3B, with the letter H. This just makes it easier in the long run when you're doing queries. You don't have to quote column names that begin with a number. All right, so I copy the DDL to my clipboard. I log into my Snowflake instance. I open up a worksheet. I'm going to create a new database named Lahman. I'll create a new schema named MLB. I'm going to drop the public schema because I won't be using that. And then I'm going to copy and paste the DDL into my worksheet and run it and see what we get. All right, so the tables are being created. And at the end of this, it looks like I got a small error. Upon reading it, it just appears that Snowflake doesn't support the end transaction syntax. So I just manually type a commit in there and we're good. So next step is to see if we could load data into these tables. All right, so I navigate over to the Lahman database in Snowsight. I click on the MLB schema and I can see that my 27 tables are there. Now I'm ready to load those 27 tables with the 27 CSV files that I have on my laptop. Before I do that, I need to create a stage. You could do a stage at the command line. You could do it in Snowsight. You could do it clicking the top right button there. Snowflake supports internal and external stages. External being Google, Azure, and obviously S3 compatible stages, whether it's AWS or Pure Storage or Cloudian or all the other usual suspects. For sake of simplicity, I'm going to use a internal Snowflake managed stage. I'll give the stage a name, and then we'll upload files to that stage. Now I'll do some spot checking on some tables and files to make sure they load correctly. So for this one, I'll take the all-star full. I'll point it to the file in the stage. You get a nice data preview so you can check data types. It shows you some sample values of the data from the different columns. And this one appeared to load successfully. Awesome. On to the next one. Just looking at the data in the table, looks good. Let's move on to the next one. We're going to do appearances. So we will connect to that. We will load the file that's already in the stage. We'll preview the data, and we'll hit the run button. Again, another one that ran successfully. So let's keep going. All right, moving on to the people table. Same process, connect to the database, the schema, select the file out of your stage that you wish to load. Now in the data preview, it looks a little different. It's showing a column does not exist. And this is something I was worried about using an older data model. So this is something I think we're going to have to go look in to the data, the actual data file, and see what our table currently looks like and what adjustments we need to make. All right, so our ID field is missing from our target table, but it is in our data file as confirmed by looking at that header file that we pulled out earlier. So we're going to shelve this one for now and move on to another table. Now we're looking at the college playing table. Same process as before, connect to the stage, choose the file, load it, and look at that, success. So let's move on and keep going. Okay, before we load the schools table, manually looking at the table DDL and the CSV file, and we do see there's a mismatch. So we're going to take care of that first before we even try loading. So we updated the table DDL, dropped the table, recreated the table, and now we're going to go through the process of loading the file through the stage yet again. And this time we see that there's another column not in the destination, but this is the last column and the sixth column, and we know because we just created this table that there's only 5 columns. So this makes me think there's some type of data issue, perhaps an extra delimiter, bad data, something we're going to have to look into the data file for perhaps. But before we do that, I want to run the copy command manually and see if we get any type of error message that's going to help us better investigate what's wrong with this data. After opening a new worksheet, I create a copy statement. Since this is a CSV file, we got to tell it the file format, that we want to skip the first row because it's a header file. We want to point to our stage, point to the file name. Always remember to, when you open up a new worksheet, make sure you're connected to a database and a schema that you want to use. You're going to get this type of error. And as we go, okay, so now we see we got an error, and it's telling us a little bit more detail about the line and whatnot. So now we could go investigate in the flat file itself. All right, so we open up the school CSV file in an editor. We're going to go down to row 98, 99 and take a look. 98 doesn't appear too bad. What I noticed about row 99 is there's an extra delimiter. Remember, we're expecting 5 fields. This makes it look like there's 6 fields. And it looks like the extra comma separating the city of Brooklyn is what's making this error. So we're just remove the comma for sake of simplicity instead of escaping it and move on. Let's see what we get. We uploaded the modified CSV file. Going to run the copy command again. Before we do that, we're going to truncate the table in case there was any data loaded. As we run through the copy, we see that there's a new error at a different line number. It doesn't tell us how many errors there are, it's just that there's another one. So we'll take a look at the flat file and confirm that this is indeed another one of those commas separating a city name. But before we do much more, we'll probably look at the copy command in the documentation and see what type of validation or error routines we could leverage, so we're not going onesie twosies trying to fix this data file. So looking through the file, we did validate that there's an extra comma in the UC Berkeley record. There's probably a way to escape these commas. What we don't know is how many of these records have multiple, or 5 or 6 commas in the record. For now, we're just going to delete this for the sake of this demo. But we're also going to look at the copy command and the syntax and see what we can do to augment that. So, going through Snowflake's documentation, very thorough. We see that there's options within the copy command to do data validation. So let's try that out and see what we get out of it. The validation mode within copy is probably what we want to do. I think giving it the return all errors option is going to tell us how many of these lines in this file exhibit the extra delimiter, and then we can decide how we're going to fix it. Okay, the copy command runs with the validation mode, return all errors, and boom, we got 33 errors. So going line by line in the school's file, we'll fix these errors. Again, not the ideal way to do it with production data, but for sake of this demo set, this will get us by for now and get us so we get to querying the data. So we'll make the adjustments to the flat file, re-upload it to the stage, and run this yet again. Running our copy command again with the validation mode turned on returns 0 rows, which is success in this sense because all it was doing was returning the bad rows. So now we could comment out that line and load the data into the table. It's great that we see success loading the 1,207 rows of the school's table, but if we step back and see what it took to get here, we start thinking about, okay, we had some data issues, we had some table issues, quite a bit of issues. We did have some success on a couple of loads, but we still have a lot of tables to load. So I think from going forward standpoint, we're going to step back and go table by table, looking at the existing header lines of the CSV files and the existing DDL of the tables, make the necessary adjustments, and recreate all the tables in Snowflake prior to attempting to load them from stage. Since we decided to load all of our data files via manual copy commands, we created a file format. We didn't catch that on video, but if you look at the create file format docs within Snowflake, walks you through the process, talks about skipping header lines, talks about the type of files, that CSV, JSON, etc. And there's a ton of options. And as I look through the docs, these are probably a couple of the ones that we could have used to get past the issue that we had with the schools with an extra comma in their name. But right now, like I said, we're just going to get the data in there so we can get onto the querying portion. The 27 copy into statements are now running. I'll leave a link to my GitHub in the description of the video. We'll have a file that has the create tables. We'll have a file that has the copy intos, and probably a file of some of the SQL that we used later and whatnot. We'll leave that in the description of the video below. For now, the tables are loading. All 27 tables have been loaded for about 5-10 minutes now. So I wanted to give Copilot, which Snowflake labels as their AI-powered SQL assistant, a try. And Snowflake Copilot says it'll help you write queries based on your data, improve your queries through conversation, explore your data with open-ended questions. There are some caveats that they might sometimes generate inaccurate responses or may take a few seconds, but they have some prompts early on. Tell me about this data, which tables can be joined, write some queries. So tell me about this data. Let's see what it has to say. All right, so it's looking at the batting table. This is really interesting because nowhere in the database are there definitions for the column names. So they're using their LLM to understand what AB is, which are at-bats, or BB, which is base on balls. So that's pretty cool. So there is a sense of looking up the definitions of these columns, seeing what type of characteristics there are out there in whatever language model they're using, documentation says it's Mistral large. So far, kind of cool. Ask it another question. How many tables are in this database? And the only table it's aware of is batting. There's 26 other tables. Again, we're 5 minutes into this. We're running on a very small warehouse. This is a demo environment. It's costing 1 credit a day. So I don't expect all the indexing to be done, in the first 5 minutes. So I'm impressed on how it comes back with some of the definitions of the column names. Let's ask it another question. Basically, who won the World Series in 2014? Again, it just says, I just know about the batting table. And, that's fine. We'll revisit this. We'll give it 10, 12, 15 hours to see if there's any indexing or learning that the AI assistant Copilot does. So we'll check back tomorrow. We'll let it sleep overnight, and we'll go from there. We are now about 14 hours after that last scene. Again, we're running on an extra small warehouse. The data yesterday was loaded for about 5-10 minutes before we used Copilot to glean any insights. It's been overnight. Let's see what we got. We're going to follow one of the predefined prompts within Copilot. It says, write me some example queries. Let's take a look at some of the queries that it brings back. All right, this first one looks like it's for the All-Star table. Second one's the batting table, college playing table, appearances table. So might as well start off with the first one. To get the number of games played by each player in the All-Star full table. SQL looks good. It's a valid query, it says. Let's run it. All right, it comes back with player IDs. It's hard to tell exactly who it is, but that's Cañada with 18 games played. Willie Mays down at the bottom with 26. Okay, that seems realistic. I don't know the numbers exactly. I would have to go look them up, but I have no reason not to doubt these. The data returned itself is valid, but it'd be nice to have first name, last name, whatnot. How about the second one? Number of home runs hit by each player in the batting table. Again, it's not ordered by anything, but that's Hank Aaron, 755. That's legit. A lot of folks have none, probably don't know who these players are. Again, it would be great if it was joined on the player table to get the first name and last name. I wonder if I could tweak this query manually and maybe just do an order by HR, see if we could get some more of the popular names that we may have heard of. So we'll put a little order by. We'll run it again. Sure, we got Barry Bonds at the top, Hank Aaron, Babe Ruth, Albert Pujols, Alex Rodriguez, Willie Mays, Ken Griffey Jr., Jim Thome, Sosa. Yeah, so that looks good. All right, that's it for Copilot right now. We'll run these other queries possibly later, but day 2 with Copilot, much better than day 1. For now, we're going to shut Copilot down and go back to some manual data exploration so we could build out some queries and explore the data sets that we have. Now we'll do some manual exploring of the data. Going back into our MLB schema, we're going to click on the people table, take a look at what we find in there. All kinds of people-related columns: birth city, birth country, birth state, height, weight, player ID, first name, last name. All right, this is stuff that we could join on other tables to make some better result sets. Let's start off with a simple query. Query the people table. We'll group by birth state, and then we'll see what are the most popular states that have had Major League Baseball players born in them. All right, California leads the charge with the most Major League Baseball players produced. Pennsylvania, very interesting, number 2. I would have thought maybe a state like Florida or Texas. New York, not surprising at all. All right, so I am from Redwood City. So let's kind of drill into what Major League Baseball players were born in Redwood City. We have 2 hospitals in town, so let's put together a quick query and take a look. All right, there we go. We got 10. Kevin Bass, former Giant. Jeff Blum. We got Eric Burns, who played for the A's across the bay. He's a Peninsula kid, went to St. Francis. Chris Carter, another player for the A's. Daniel Descalso, San Carlos kid. James Outman, he is on the Dodgers roster, 40-man roster right now. Unsure if he'll be on the World Series roster, but he's a Redwood City kid. Cool. So in honor of Snowflake's office in San Mateo, let's take the same query, but kind of clean it up a little bit. Let's make it a little bit easier to read, not as many columns. But we're going to use basically the same predicate, but San Mateo. All right, a little bit bigger of a result set. We got 19 rows, starting off with Bud Black, longtime player manager, currently managing the Colorado Rockies, Champiano out of Serra High School, the Goodell brothers, a set of brothers that made it to the big leagues about 10 years ago. Gratz out of Burlingame, McClellan out of Sequoia, very cool. Dick Sharon, Kennedy Middle School Hall of Fame, Sam out of Aragon High School. So Pete Sweeney was a really cool one. I had to look him up. Born in 1863, broke into professional baseball in 1888, and played through 1890. So pretty amazing. Born in San Mateo, December 31st, 1863. Next up, let's explore the table that gave us so much trouble, the schools table. We know that there's 5 fields in there. It has a list of all the junior colleges and colleges, at least in the U.S. I don't know if it's worldwide. Also notice that there's a college playing table, so there's probably a linkage there on the people table. So let's start building some queries to explore different college stats for the players. Keeping it local here in San Mateo County, a lot of great baseball players that come out of here. San Mateo County is home to 3 junior colleges with quality baseball programs. So I noticed some of them in the schools table. So let's query the schools table to see if we could get those 3 college the full names out of the table so we could use those in subsequent queries, check out players and whatnot. Here we have our 3 schools. The first one is actually Cañada, not Canada College. We'll fix that data. Out of Redwood City, College of San Mateo, and Skyline Junior College up in San Bruno. So let's fix that Cañada College data entry. Just a quick DML update statement to update the Cañada College to the appropriate spelling. There's a tilde over the N. And we're good to go. Let's write a query that will count how many Major League Baseball players have been produced by each of these junior colleges. To make the output a little bit more readable, we'll concatenate a couple of fields, give the columns new titles, and run the query again. After we do that, we'll dig a little bit deeper and we'll join to the player table, or the people table I should say, and understand who are the first names, last names, and years that these players played at these schools. All right, a pretty cool list going back to the 60s. A lot of big names there. See Harold Reynolds, you'll catch him this week on Major League Baseball Network doing World Series coverage. Bob Melvin, current skipper of the San Francisco Giants. And yeah, Ronnie Callaway and Scott Feldman, the last 2 to make it to the big leagues from Cañada and CSM respectively. One last query around schools. Which university in the United States is the most prolific in creating Major League Baseball players? So let's put together that query and see what the output is. Not surprising, we have University of Texas Austin, USC, Stanford at the top of the list, what is surprising is the actual count. I was expecting it to be more around 100. This makes me think that the query is a little off, so let's take a look and see if we could rewrite it. So this is where it pays to explore your data and understand the data that are contained within your data files. In this case, there's 1 record for each year that a player played at a university. So if a player played 1 year, 1 record. 2 years, 2 records. 3 years, etc. So we need to pull out the distinct player from each school. So let's do that. All right, I'm going to take a stepped approach to this query. I'm going to write a smaller one, isolate it to one single school, and see if I get a realistic count back, which I said was I'm estimating about 100. I don't know the exact number, but that's what I expect. So let's see what this query comes back with specific to Texas. All right, building off of that logic that we just created, we're going to pull out the Texas predicate. We're going to use kind of a nested subquery type of approach here to ultimately get the distinct player count per school. Let's see if this works. Yeah, those numbers look a little bit more accurate. Looks like Stanford slid down underneath ASU, and that could be for a variety of reasons. How many years does a player stay out of school before they leave for the major leagues? Here we're looking at the series post table, and I saw an interesting column in there. It was called round. Round had what round of a particular series the team went to. Also had winners, losers, league winner, league loser. Values were WS for World Series, CS for Championship Series, probably some NLCS, ALCS types of things. So let's build a query around this to give us a list of all the World Series winners in descending order. Cool. There's a nice list starting from last year's winner going down. You got Bochy, you got Dusty Baker. Sweet. We can make this a little bit nicer with team names. So let's join it against the team table and see what we could do with it. Yeah, that's much nicer to read. Well, looking through the teams table, I noticed a column called WS win, and the value is either yes or no, or sometimes null. I believe this is, did they win the World Series that year? So let's build a query off of that. Let's just order total World Championships descending by team and see how that looks. Oh, and there we go. Obviously, Yankees leading the way. Snowflake has the idea of dashboards. So let's build one of those. This is not going to be able to compete with a Tableau or a preset or a looker, but it's handy to have within your own Snowflake platform. Pretty easy to create. I'll create a dashboard and add tiles. The tiles could be from SQL worksheets or Python worksheets. This is a very simple example. I'll use Nolan Ryan as the pitcher, and we'll just put up a couple of different tiles showcasing his strikeout numbers per year. Okay, I'm going to open up a new worksheet, connect to the database, and open up Copilot for the third time. Let's see if there's any more insights we could glean from Snowflake's Copilot. I followed one of the built-in prompts, tell me about this data. And Snowflake definitely knows more about the data model than it did yesterday. As you can see, yesterday it just knew about the batting table. Now we got All-Star, college playing. Goes into some details about the different columns and whatnot. So it's definitely learning the data model. Let's see if we could continue to ask it questions. So I'm going to give it kind of an arbitrary question. Snowflake already knows that BB means base on balls, so ask it about base on balls. Who had the most in 2023? But this could be a pitcher or a hitter. So we'll see what approach Snowflake Copilot takes. So it looks like it went to the hitting side of bases and balls and constructs a query. It says it's a valid query. The query returned data, but it doesn't look correct. If someone had 2,426 bases on balls in a year, they would not be in the major leagues. So this query definitely needs some more work. I'll now ask who led the NL in 2023 in batting average. So again, batting average is a formula. It's not in the database. It's not a stored value. So Snowflake AI's Copilot needs to figure out what batting average formula is. And it actually calls it out here. So when it builds the query, it's using the correct formula. Sum of bats divided by sum of at-bats is batting average. So let's run this. First glance, query looks good. Let's hit the run button and see what we got. Ooh, division by 0. Yeah, so something's up with that. Maybe it's missing data. Maybe it's a bad query. Not sure at this point. Next, we'll ask it, who was the World Series MVP in the 2014 World Series? World Series MVP is the value of the data inside of the column, so this will maybe make it a little bit easier on it. So let's see what Copilot comes back with. Tells us what tables it's looking for, what it's joining on. Yeah, Madison Bumgarner. It's not the first name or last name, but it is the player ID, and that is the correct answer. In the next prompt, we ask, how many World Series has the NL versus the AL won? Granted, the prompt could be probably cleaner, but let's see what Copilot comes back with. All right, so Copilot builds a case statement. On the outside, it looks good. The predicate in the round doesn't look good because I know there isn't a World Series value in that column. So I'm not surprised that this query didn't produce results. So if I modify that value manually, because I know in that column it's WS, let's see what we get. All right, we got 123 to 3, which is not accurate, but it is a result. So we're getting closer. Looking at the query, I wonder if there's something we could tweak. Perhaps it's a group by. What happens when we change the group by league to group by league winner ID? Will this help us? Yeah, these results look better, 58 to 67, which I think is more in line. The AA there is probably pre-MLB World Series. Take a quick Google. What are we? All right, the values are considerably off, especially on the National League. I think this might be because the World Series didn't begin until 1903, and perhaps these additional National League records are being attributed to the pre-1903 leagues that were in professional baseball. So let's try this again with a predicate on your ID that's greater or equal to 1903 and see what we get. There you go. Much better in line. Still off by 1. That could be a variety of reasons, but a lot better than what we were looking at. Good job, Copilot. Let's see if we could coax a prediction out of Copilot of who's going to win the 2024 World Series that begins this Friday. Is it going to be the Yankees or the Dodgers? And Copilot says, my apologies, I am unable to answer that question. So the interesting thing here is I ask it the same prompt, but without the question mark, and it gives me a slightly different, more elaborate, not elaborate, but more detailed answer. Just a couple more questions here for Copilot. Who has more World Series championships, the Yankees or the Dodgers? It's interesting that Copilot does come back with a common table expression, which was interesting. SQL looks good. Unfortunately, when I ran it, it didn't return any results. Part of it could be, the round again. It says World Series. And one final prompt for Copilot. Again, I probably could have been better with how I said World Series instead of the World Series saying WS. But who won the 2014 World Series? The query it generates uses the value World Series in the round predicate. Of course, doesn't return any results. But upon modifying that predicate, guess what we get? Go Giants. So one last effort to help Copilot out, providing a better prompt using the WS value. Let's see what we get here. And of course, it creates a query using the term World Series. So thanks, Copilot. Pretty impressed with some of the stuff. Gets users that aren't familiar with SQL kind of pointed in the right direction, but pretty interesting stuff. As mentioned earlier, I'm going to export the DDL and post it to my GitHub. I'll link that in the description below. But Snowflake makes it very easy to get to it. The get DDL function it could take a variety of arguments, table level, schema level, database level, depending on what you want to export. For what I'll post on GitHub, it'll be at the database level, so you'll get a create database statement, all the table statements, you'll get the create file format statement. So it's pretty cool, really easy, single function to run. No need to run any type of backup software and dig through your backup file or whatnot. It's really nice to have this stuff at your fingertips. Quick copy and paste into your favorite text editor, and you have a backup copy of your database's DDL. I've had a lot of fun getting to know Snowflake over the past month or so. The database concepts themselves aren't new, but just the ease of use is really nice. The worksheets, it's great to be able to go back in time and look at some of your history. You do get a little bit of worksheet sprawl, if you will. I found, I'd be working on a sheet where I had a few SQL statements. Then the next day or next hour, I might open up another one. I would start losing track. But it's more user than the platform. I love how you could go in and look at your objects, your schemas, be able to create new objects with the click of a button. Go into a command line to a worksheet, or you could download the Snowflake, Snow SQL for your laptop. That's great. Been doing that type of stuff for years. But a GUI is nice. It's easy to copy, look around, see data previews, data lineage, being able to just copy DDL and whatnot straight to the clipboard without trying to format things. So there's been a lot of nice shortcuts that it's been fun to use. A lot of things we didn't even touch on, the data products, the data marketplace. There's a lot of third-party tools, BI, analytics, geospatial. That'd be pretty cool to put on top of some of this baseball data set. I think what would really be cool is if Sabre became a provider to the Snowflake Studio. Think of an S3 bucket having those CSV files sitting there. So now with Snowflake user, all they need to do is create a stage and point to that S3 bucket. They don't even need to load into their database. You create a view on top of those S3 files, and now you're using it kind of in the data lakehouse concept. But if Sabre just uploaded those 27 files, they'd be sitting there for anyone to use. So I think that would be pretty cool. But yeah, the platform in general, data is at your fingertips, however you want to use it, whether you want to create a dashboard, do some SQL. Copilot has some promise, I think. I think it's like anything, how good of a data model, how good of the referential integrity you have, how good you describe your columns. As well, it's the person providing the prompt as well. How accurate is the prompt? How clarifying is the prompt? My database, I didn't take time to create foreign keys. There's no referential integrity. I knew some of the columns and what the data contained, and I would purposely ask Copilot things that it wouldn't inherently know, and it did a pretty good job. Like I said, any formulas that it had to do, it'd be interesting to see if it would have done earn run average for pitchers. I didn't ask that. And some of the advanced sabermetrics, wins above the replacement, all those types of things would be interesting to see if Copilot could handle. But again, it's kind of garbage in, garbage out. You provide a good data model, good data, and good prompts, you'll probably get better returns. So all in all, it's been fun to do. It's been a cool little project. Hope everyone enjoyed it, and enjoy the World Series starting Friday. And go Giants.